If you'd like, you can use a formula to find a specific percentile in a data set. The formula looks like this: I equals k divided by 100 times the quantity n plus 1. I is the index, or the ranking of the data value. We'll calculate I. That tells us the position of the number that we're looking for, and then we go look for it in the data set. To calculate I, we need to know two things: the percentile we're looking for and the number of data values in our data set. Let's give it a shot. We're looking at a list of 29 ages from Academy Award-winning Best Actors. They're already ordered for us, smallest to largest. That way we can find the position easily after we calculate I. We're asked to find the 70th percentile. In other words, we're going to use k as 70 in our formula. And we know that we're looking at 29 ages in this list, which means we have 29 data values. So n is 29. We want to calculate the data value position for the 70th percentile. So we will take our formula, solved for I. We're going to plug in 70 for k, and then we'll plug in 29 for n. Before we type that into a calculator, I recommend simplifying just a hair. 70 divided by 100 turns into the decimal 0.7, and 29 plus 1 turns into 30. We can probably do this calculation in our head. 7 times 3 is 21, but we have 7 times 30, and then we need to take into account the decimal, so I would move my decimal in right here. So 0.7 times 30 is 21. That tells us that the 28th percentile is the 21st data value in our data set. Now, I've listed these data values out so that they're quick and easy to count. We have 5 in each row. So we have 5, 10, 15, 20 data values in the first 4 rows. The 21st data value then would be 64. So our 70th percentile is 64. Sometimes this formula will lead to a I value that is not a nice integer like 21. And in those cases, we have to do a little more work. So let's take a look at the same data set, but this time let's find the 83rd percentile. In other words, we're going to use k as 83. Same data set, so n is still 29. Therefore, I is going to be 83 over 100 times 29 plus 1. That's going to look like 0.83 times 30. Now this one I'll pull out the calculator for, so we'll type in 0.83 times 30. We get 24.9. Now we don't have a 24.9 position for a data value. Our data values are in the first spot, or the second spot, or the third spot, but not in a 24th.9 spot. That doesn't really exist. So when you calculate the position, the index for your percentile, if the result is not a perfect integer, then you're going to round up and round down. You'll round the index up to 25, and you'll also round the index down to 24. We will look at the 24th data value and the 25th data value and find the average between those. We know that 64 was the 21st data value, so we can conclude that 72 is the 25th data value, and therefore 73, whoops, wrong direction. I don't want the 26th, I want the 24th, and 24th data value is 71. We need to average these two values to find the 83rd percentile. So P83 is the average of the 24th and the 25th data values. So we add 71 and 72, cut it in half, we get 71.5. There we go. The 83rd percentile is 71.5. So when we use this formula, we have to be very careful that we don't interpret the value for I as the percentile. Notice that when we were looking for the 83rd percentile, I was 24.9. We had to round that up and down to find the correct two data values to average. So 24 and 25, again, are not the value of the percentile. They're telling us where to look in the data set to be able to find the value of the 83rd percentile.